Alrighty, so this is the second video where we're trying to explain the electroscope demos that we're doing. This is for Electroscope Demo 2, so again, if you haven't watched that demonstration, make sure that you do. In that particular demonstration, we started out, if you notice right here, with a positively charged rod, and we started with a neutral electroscope. So again, I want to add my electrons to my electroscope. One electron for each positive charge here. So that produces an overall charge of 0, or neutral. And like we saw with the other video, we're not actually touching the rod, the charged rod, to the electroscope. So you can't get a movement of electrons from the rod to the electroscope, or from the electroscope to the rod. We didn't see a spark happening, so nothing's traveling through the air, and you need physical contact in order for electrons to be transferred like this. So the only thing we can do is use the laws of attraction and repulsion to show where the electrons are moving in the electroscope. Okay, so again, the rod is positive, and the electrons that are in the electroscope, and again, they have the ability to move around, those electrons are negative. So what do the laws of attraction and repulsion say when there's a positively charged rod near negative electrons? What do opposite charges do? Well, they attract, right? And so what happens is this positively charged rod is going to be pulling electrons up to the top. Okay, so I'm going to put a big A here to represent attraction. So these electrons are going to be pulled upwards towards the sphere, because that's the force of attraction towards the positively charged rod. And so what we can do is take those, 12 electrons here, I think it is, 10 electrons, and we're going to put them all at the sphere up here, and as many as we can, stuff them in there. So that's 7, 8, 9, 10, 11, actually we only need 10. So 10 electrons right there. So all these electrons have moved up towards the sphere because of that pull, that force of attraction being exerted by the positively charged rod. And electrons again can move through the electroscope because the electroscope is made of metal. Okay? And so what do you notice about the leaves now? The leaves are left with a positive charge. And so what they're going to do, as we saw with the demonstration, is that they're going to be left with a overall positive charge, and they're going to repel each other. Okay? And that's exactly what we saw with the demonstration. When we brought that positive charge rod close by, the leaves spread apart. Well, here's the reason why. Electrons move to the top of the rod and the sphere of the electroscope, and then left the leaves with a positive charge, and again, like charges repel. Okay? So we'll see you in the third video.